We're going to take a look at chemical weathering. So here's a beautiful picture of Moab, Utah. Um, and you can see that this, maybe millions of years ago, was a plateau that's been weathered away by uh, both chemical and mechanical weathering, and it's been eroded away too. Um, what is the difference between mechanical weathering, chemical weathering, and erosion? Weathering is the process by which rocks are broken down. Mechanical weathering is the physical breakdown of rocks. So when a rock just breaks into smaller rocks, but it's still the same kind of rock, that's mechanical weathering or physical weathering. Now, chemical weathering is the breakdown of rock material. During chemical weathering, the atoms are rearranged, forming different compounds. Unlike mechanical weathering, chemical weathering involves a chemical change to a rock or mineral on a molecular level. So basically, when it's a chemical weathering, the rock turns into a different kind of rock, or a different kind of substance of some sort, like a liquid or something. So when it's a mechanical weathering, the rock just gets broken down or cracked, but chemical weathering is when the rock actually, there's a chemical reaction and it actually turns into something different. An example is rust. So rocks that contain iron in them, they rust and they're no longer the original rock. They've become something different. So that would be chemical weathering. And erosion, we've talked about, is the process by which weathered rock materials move to a new location. Now, all three of these things work together. It's mechanical weathering, chemical weathering, erosion. They all kind of are happening simultaneously. What causes chemical weathering? So this is when a rock actually turns into something different. It could happen with reactions to oxygen. So rusting is an example of oxidation. That's a fancy word, oxidation. But the word we usually use is rusting. So rocks that contain, like for example, iron, or there's other minerals that could be in a rock, and the rock actually rusts. So that's a chemical weathering. It could also happen with water. Dissolution occurs when rocks or minerals dissolve in a liquid, usually water that is at least slightly acidic. So water picks up acid from the soil, or water picks up acid from the air. It's not like purified water. So the water that's in a stream or comes down from rainwater, it has acid in it, and then that acid, it could just be a very slight acid, but it'll chemically weather a rock. So we call these agents of chemical weathering. So in other words, these are three things that cause chemical weathering. So oxygen could cause chemical weathering, water could cause chemical weathering, and acid could cause chemical weathering. The acid could just be like from the air, from like air pollution. It could be acid that's in water, or plants or microorganisms and their roots have acids in their roots. Not like, I think when I say acid, people think of like this like burning poison, but acid is just, it could be a very slight acid. And also people with pollution, we put a lot of pollution into the atmosphere, and then that causes chemical weathering. How do weathering and erosion work together to change Earth's surface over time? So these two things work in tandem. Chemical and mechanical weather work in tandem with erosion to reshape Earth's surface. For example, chemical weathering is often preceded by mechanical weathering. So that means mechanical weathering happens, and that leads to chemical weathering. Mechanical weathering opens cracks in rocks and breaks rocks into smaller pieces. This provides more surface area for the rock to interact with agents of chemical weathering. So you can see in this picture here, the water, the waves probably broke this rock apart and caused it to crack and get into all the much more cracks and bumps and stuff from the waves. So that was mechanical weathering. But once those waves get in there, then if there's acids or salts in that water, then that can start to chemically change the rock too. So then mechanical weathering happens, and it's followed by chemical weathering. They work together. What factors affect the rate of chemical weathering? So sometimes chemical weathering could happen really slowly or it could happen really quickly. That's what we mean by rate, the speed of chemical weathering. Um, could be the rock type. So if there's rocks that contain iron, they could rust really easily. If that rock is like buried deep underground, then it won't, come to the surface for millions of years. But once it does, then it starts to chemically weather. Exposure, what that means is if a rock starts to break apart, more sides of the rock are exposed to air or wind or water or acids. So then the chemical weathering would happen faster. So if it's a big rock, then chemical weathering might not be affecting it too much. But then it breaks apart, and now these little pieces, chemical weathering can break those down really quickly. Another thing, climate and air quality. So in warmer climates, there's going to be chemical weathering from rain and from the acids in the soil. In a colder climate, there might be less chemical weathering from rain, because there's not as much rain in the colder climate. Now, air quality, if it's an area there's a lot of pollution, then then that pollution gets into the rocks too and causes more chemical weathering. Okay, that's the information you'll need, the basics for chemical weathering.